Unity, and welcome back to another official Unity live stream here on both twitch.tv/Unity and, of course, the Unity YouTube page. My name is Jackson. I am one of your community managers, and it is my responsibility to bring you all of this live stream content. We are live every week on Thursday at 9 a.m. Pacific time. That's 12 noon Eastern, or 5 p.m. GMT. So thank you so much for joining us. We have a fantastic show planned for you today with two incredible guests with a lot of knowledge and insight. I'm excited to get into your hands/ears, because that's where knowledge goes, into the ears. Natural. You didn't need the explanation. But if you are watching live on either Twitch or YouTube, please be aware this is a conversation. We want to hear from you. We want to connect you with our guests. I will be here to facilitate any questions you might have for our guests. There's going to be a lot, I think, so make sure to fire them our way. Right now, if you're hanging out with us live, please let us know where in the world are you tuning in from. Again, one of my favorite things with the Unity community is seeing just how broad and international this reach of this community is. If you are watching after the fact as a VOD, take a look down at the navigation bar. We will have this conveniently chaptered out for you so that you can pop ahead to whatever section might appeal to you most. Of course, thank you for those of you joining us here live, like Lavi, Mwenmen, Angel, Cruz on the Twitch side. We've also got My Real, The Bull, Rogue Shadow, Noob Zem, Felipe Gama, Delphs Bryn, to mention just a few. Thank you all for hanging out with us. Again, we're going to have a lot of opportunity throughout the show for you to ask questions to our guests. So feel free, fire away. If they align with what we're talking about, we'll make sure to ask them when we can. Otherwise, we will hold questions for the end, where we will have a dedicated Q&A time. All right, let's dive into a little bit of housekeeping before we jump into the show. I have a survey for you all that I'm putting in the chat. This one, very simple. One question: what is something you would like to learn on the Unity live streams? Especially in May, June, and July, we're looking to ramp up our live stream production. I've got a lot of plans for you all, but I want to hear from you. What is something that you would like to learn? That way I can go and search. And if there's some alignment and like half of you want to learn one particular topic, I can go and find someone to teach you that topic. I think it'll be a lot of fun. So feel free when you have a moment to go and check out that survey. Again, I want to hear from you because, again, we're building this community with you. And I want to be able to help facilitate your questions, your comments, your learns, et cetera, et cetera, et cetera. Of course, we also have exciting news. The Unity team has written a book. The Career Game Loop, Learn to Earn in the New Economy, launches on April 29th. It's all about how you can approach your career like a game by embracing adaptability, continuous learning, and strategic growth. If you are in the US, you can get a free copy by following the link in chat. If not, that book will be available internationally at the end of the month. Keep an eye out for that, as there were many contributors from inside of Unity. All of the proceeds actually go to Unity's charitable organizations as well. So keep an eye out for those opportunities. I want to bring in a comment right now from Denny Ramadan. Dredge is underrated. 100% agree. It was my game of the year that it came out. We also talked to the team at Black Salt Games last November. They were fantastic. But today we're going to be diving in and talking to you all about how Unity Studio Productions ported Dredge to mobile. This is a pseudo presentation from GDC. We've adapted it. We said, hey, why not bring it to our community here on these channels? So you all are in for a treat, as we're going to show you something that previously was only reserved for a live audience in San Francisco at GDC earlier this year. So I'm excited to dive into it. I think I've been talking nonstop for 4 minutes, so I think it's about time we bring in some guests here. Please help me in welcoming to the show. For the first time, we got Joe and we have an Alex. Welcome on in, gents. How are we doing?
Right. Excited.
Good. Very good. Welcome on in. Again, both of you first times on the stream, so thank you, firstly, for joining us, electing to take some time out of your day to talk to us about this presentation, but then also just sharing your general knowledge and experience here. It's something that I'm so fortunate to be able to do, is connect our audience, our community, with the people inside of Unity, so that Unity is no longer just a faceless corporate logo and name. And instead, people can see, hey, there's real people, good people, excitable people, passionate people working on these projects. So I'd love people to get to know you just a little bit. So Joe, I'm going to turn our attention to you briefly here, but like,
Sure thing.
How long have you been at Unity? What do you do here? And tell us a little fun fact about you, because I know you've told me one, and I'm hoping that's the one you elect to share.
Sure. Okay. Sure. Yeah, my name is Joe Cruz. I have been at Unity now for about almost 3 years, and I am a senior technical artist in the company. As for a fun fact about myself, well, you could probably guess from my background, I am a working composer. I've actually written some compositions, mostly for documentaries, but I've done a video game. I've written the soundtrack for Blade Runner Revelations, which was a Google Daydream game back in 2018, I believe.
That is very, very cool. You also used to DJ at clubs. That was more where I was leaning to. But like, yes. An illustrious music career to align with your technical art and all of the work you do here. So Joe's got layers is what I'm saying. Like an onion. You know what I mean?
Like an onion.
Like an onion. Yeah.
Not as smelly, hopefully, like an onion, but yes.
Yeah.
Yes. Yes, I've DJed mostly in the West Coast, Vancouver, Seattle, and LA. So, but yes, ever since the pandemic, I've kind of eased off gigging in clubs, and that's when I started doing more soundtrack work.
And now look at us. Joe. It has brought us all together. Alex, we're going to turn our attention to you. Who are you? What do you do? How long you been here? Tell us a little about yourself.
Yeah, I'm Alex Bedard-Reed, senior software developer at Unity. I've been here for about 3 years now, just a few weeks away from 3 years. Unfortunately, no DJ career here, but I guess if we were to just kind of touch on some inspirational games for me, Portal 2, if it wasn't already obvious, Factorio, just kind of keeping it basic. Those are nice comfort games for me. So, yeah.
Well, welcome to the show, both of you, Joe and Alex. So much of the work that you have done on porting Dredge to mobile is very indicative of some stuff that's going to be coming through the pipeline. So I'm very excited for you all to share this information with our community, but then you, community, I'm excited to kind of tell you where we're headed with some of this live stream content in the next few months, because we're going to be breaking into some really, really cool things. But Unity Studio Productions, as we kind of dive into an overview of it here very briefly, but like, it's unique because I don't think enough people know that this exists, that Unity helps create games, that Unity is making games, that these things are happening. In fact, I went, hey, Unity Studio Productions probably has its own webpage. It probably has its own link off on unity.com, and I couldn't find it. So I think you guys are kind of like a best kept secret, for better or for worse here. Can you tell us all a little bit about Unity Studio Productions and what that's all about?
So yes, in the presentation, I will go at length about it. But yes, you mentioned we're a bit of a best kept secret. I definitely got that vibe on GDC when I first gave this presentation, because as you'll see in this presentation, we made custom solutions, right? That that don't really come out of the box out of Unity, and when you use the editor, but the solutions that we came up with to get Dredge to run in a performant manner on mobile, where the audience response was actually very enthusiastic. That they came up to me in the Q&A and they were asking, "Oh, are we going to have that in version 6 when it comes out?" And I'm like, "Yeah, well, it was." As I will mention, we make custom solutions for our clients, right? And yes, so I'll get a little bit more in depth, with USP. Alex, do you have anything to add?
No, I think you summed it up perfectly. So,
yeah, I think incredible to see you guys working on Dredge. Again, we mentioned underrated. One of my favorite games the year that it came out was my game of the year. But the team has worked on other games as well. it has put in work in collaboration with the team behind Den of Wolves, which is the follow-up from 10 Chambers, who created GTFO, for those of you that are familiar. And that game's on its way at some point, and it looks beautiful. But then also more recently announced was the work that the team's done on Survival Kids, and that game got announced alongside the Switch 2 presentation as well. So our hands are definitely tied on what we're able to discuss and disclose at this point in time, in that it's basically nothing. But why I'm excited to talk about it is, in the next little while here, we're hoping to bring you some live stream content about the work that team did to create a game from the ground up, in collaboration with other producers and things like that, and kind of break down the actual steps and dive into it. I know it's this underlying reputation that we see sometimes at Unity, that Unity doesn't play with their own tech. They don't make a game, so they don't know what me as an indie dev, they don't know what it's all about. So we're here to kind of say, no, there are people actively doing it. You two are some of them, not all of them by any means. And I'm excited for the next couple of months as we continue to unravel that a little bit and bring the audience and the community this perspective of how we actually made those games and the technical side of things as well. So anyone who's been nervous about Unity not dogfooding, don't worry about it. Now, dogfooding for me was a brand new term that someone said 7 times in a meeting before I went, I need someone to stop and break this down for me. Now, maybe I'm the only one, but can one of you define dogfooding for us?
Jackson, I'd say I was definitely in the same boat not too long ago.
It wasn't just me then.
So yeah, you're not alone. You're not alone. It essentially means that we use what we make. So I am a game developer. My background is game development. I use the products, and we take that feedback. We bring it back to the teams so that we can continue to improve on the products that we have. So it's not lost that we're aware of everything that's happening. We use it every day, and we have the feedback as well.
Yeah, I think inevitably when it comes to game engines and game development, etc., people draw comparisons, and I like to say it doesn't matter. On my end, use the tools that work best for you. If you're going to go and make cool games and you're going to use Unreal, that's fantastic. Go ahead and make cool games. What's good for the industry will be good for us in the long run. Anyways, we all want to see cool things being made. But, this conversation around dogfooding, Unreal has obviously Fortnite. So naturally, you're going to see people being like, well, they know the engine because they have this game that they do it. And Unity doesn't do that. But again, we do to multiple layers. And today we're going to kind of dive into seeing just what that process was like for you both. So thank you again for being here, for being willing to chat and show off the work that you do. Again, I think the streams are such a fun time where we can be like, you guys do all this work behind closed doors. And sometimes it's in front of people and nobody ever really knows. So to be able to kind of bring you in here, brag about your work, set you up on stage, put a spotlight on you, and then connect you with an audience that's like, cool, I like this work that you've done. I think it's such a fantastic opportunity. So Joe, Alex, again, thank you for being here. And with that, I think we're pretty much ready to kind of dive in here. I know that you guys have this presentation, again, adapted from GDC earlier in the year. The floor is yours. I'm going to be here, again, connecting you and the community. If you guys have questions, feel free to fire away. Otherwise, we will hold them to the end. We'll have a Q&A session to end the show and lots of opportunities. So if you guys have curiosities, please let us know.
Sounds good. All right. Well, thank you so much, Jackson. And welcome everyone to this live stream and to this presentation. So yes, as mentioned, this used to be a GDC a presentation that I gave just last month, right? And so this is about getting Dredge to look great and run cool. Right, so it's a very punny title, right? Because you'll see, as this presentation goes on, that thermal efficiency actually plays big when you are porting to mobile. All right, so we are Alex and Joe. We are your presenters for today, and today this is the agenda we've got going. Firstly, let's get an overview, obviously, of what we're going to talk about. The mobile port for Dredge was done by my team, Unity Studios Productions. So we'll talk a little bit about what this group does within Unity. Then we'll discuss briefly about the game itself. We'll also talk about, some considerations to porting to Android, namely the integrating Google Play Games services. Then we'll also discuss some considerations and some challenges we encountered while porting, to the Android ecosystem. We'll talk about our optimization plan, namely the Android Dynamic Performance Framework. We're going to talk about the VK Quality Toolkit, which proved to be very, very useful for us for device selection. Then we're going to talk about some of how DREDGE implemented touch control and how we optimized touch control for mobile. We're going to talk about memory profiling, converting your shaders to make sure that it is compatible with a scriptable render pipeline. We're going to talk about vertex reduction, terrain optimization, as well as optimizing vertex animation. Then we're going to talk about our results. What did we find that was useful and what could be potentially useful for your projects as well? And then we'll round it out with a Q&A.
Yep. I think this is super exciting. Great overview. And I think, again, already, Joe, you're doing it, but taking all of the results and findings and saying how this could be useful to our audience, I think we're not here to talk at you. We want to equip you, audience, with things to help you improve and get better. And we know that's why you want to be here as well. So hopefully, as we kind of wrap up, we'll be able to give you all of that information and say how it's directly applicable to what you might be trying to do in your own projects.
Indeed. All right. Wonderful. So, okay, let me talk about Unity Studios Productions. So we are basically the client-focused arm of Unity. Okay, we engage with game developers and we collaborate basically in developing custom solutions for your projects. So we can do consultation, custom development, we can do optimizations, among others, right? So all of us, we're industry veterans, okay? Many of us come from production and development backgrounds. We've worked in game studios ourselves, all right? We're driven by a love for the games industry, and we represent literally collective decades in Unity game development. So we treat every game and every project as if it was our own, right? So now one great thing about creating custom solutions and custom development, right, work is that we get to work and collaborate on your project, right? So this means that this helps us validate our tools, right? And it validates the tools and services in actual games, right? So our aim is to validate this technology and investments with real games, so that if we're investing in things that totally matter to you. So a case in point, in DREDGE, USP deployed our small team to find optimization opportunities. And then we either implemented or provided those recommendations for those optimizations. So we believe in giving back, more than just technology. We also, it's important for us to give back in terms of content that helps you apply better practices for your own projects. So this is, Jackson and Alex, this is where the idea of dogfooding, right? Product verification, right? So we validate the tools and the techniques that we develop for our projects and see, are they actually useful for the community at large?
I still need to find the etymology of the origins of dogfooding. To me, it still doesn't make sense. I don't know. I'll do some deep dive knowledge and I'll come back and hopefully I can share that in the results portion of the stream. You know what I mean?
Wonderful. All right. So I want to talk about DREDGE now. So DREDGE is a very beloved IP. Okay, it is an eldritch horror-style fishing adventure. It's a single-player experience, right? Created by Black Salt Games, which is an indie developer based in New Zealand. It was ported by Cerebral Fix, Black Salt Games, as well as Unity. There are 2 DLCs available now: the Pale Reach and the Iron Rig, which is very fun. It's available currently in PC, Switch, Xbox, and PlayStation, and has been ported to iOS, Android, and Mac OS. Now, there were multiple teams that played vital roles in developing the mobile ports. Black Salt Games is the primary developer of DREDGE. They were also responsible for providing oversight on the product and its direction and implementing the optimizations. Cerebral Fix provided the bulk of the port work, and they focused on redesigning the player UI and user experience. As for us in Unity, we were specifically responsible for implementing Android features and optimizations. So now we're going to talk about porting to Android. So I will turn this part of the presentation over to Alex.
Awesome. Thanks, Joe. Yeah, so when we were first evaluating the game, we looked at what features in particular stood out to be fixed or to be implemented. So one of those things was the synchronous file saving and loading. So when implementing the Google Cloud Save, they utilize an asynchronous cloud saving system, which didn't align with the synchronous setup that existed already. So we wanted to be able to utilize that. So that was one of the things that we were looking at for as we were doing this port. There were some limitations on how the achievements were implemented. So Play Game Services, I'll probably say PGS as we go through the presentation, but provides the option to use achievements and progress. So like, if you have a percentage completed on any particular achievement. But the way that Dredge had implemented it made it so that it was either you had it or you didn't have it. And it just became, or it wasn't really realistic to refactor the entire system for all of the platforms to support the progression. So we just stuck with that system, but just know that that is something that exists. One of the things, though, is PGS unfortunately doesn't have the ability to have achievements with specific content. So for us, that was an issue with the DLC. We were hoping to be able to include achievements specific to DLC, but because that wasn't an option, they're just there as hidden achievements. One of the other issues that we were trying to work around was the single scene. So the game scene is a single scene with everything sort of loaded in there. Means that, load times are something to be considered, but also as things are loading in, there's lots of things instantiating into the scene, which could add a lot of overhead. But for us specifically, we're going to be looking at the fishing locations and how we can make improvements to that. One of the other systems that existed was In Control. So that's an input system plugin that can be added into the project. And that was something that was already within Dredge. But its inclusion of the touch control functionality made it so that there was some additional overhead that we needed to look at. So that's, running multiple cameras is not free. So we had to make sure that we were taking a look at that. If you want to hit the next slide, Joe.
Sure thing.
Thank you. So some of the optimization challenges that we were looking at. So when we came in, the camera far plane. So like when a camera exists, it has like a near clip and a far clip plane, which just is what's drawn. Everything within this little box is being drawn. So that far clip plane for us, when we came in, was 5,000 units, 5 kilometers, 5,000 meters, however you want to think about it. So this needed to be that long so that we could be able to maintain visibility on the lighthouse. So as you're playing the game, the lighthouse is the sort of center point to the map, so you can always understand where you are as you're moving around. One of the things that we were able to do was just like reduce it to 2,500 meters, which is, big improvement because it means that we're drawing less things. We'll get more into it, though, in the later slides. Some existing optimizations that were in, they included BSG, Black Games included specialized culling scripts that were applied to some of the larger things, so like islands and villages or towns or buildings. Occlusion culling was included on the camera, which is great because you don't want to draw stuff if you can't see it. And finally, level of detail or LODs were used on, most of the things that you'd want them on. So islands, buildings, ruins, etc., including the water planes. Mm-hmm. But some of these things all required some finessing, some work. So the LODs that were included when we came in were a little bit heavy, so we needed to make sure that they were improved so that they were less intensive. And then also just their draw distance. So if you think about an LOD, which we can break into if we need to, but LODs have levels. So 0 is sort of like the highest fidelity mesh. And, for us, LOD 2, which is the lowest fidelity mesh, is how it's spaced out. So when we got to LOD 2, there was still a lot of geometry, and they were still being drawn at far distances, which wouldn't make a lot of sense just because it's pretty expensive. Would you hit the next slide, please?
Sure thing.
So in terms of our porting and optimization plan, so we wanted to focus around the Android system. So that's what we were there to help with. So that is integrating Play Game Services, PGS. We wanted to make sure that the Android Dynamic Performance Framework was in. So I'll be calling this ADPF as we go through, but if I say the acronym too much, just let me know. I'll say it again. So we wanted to look into reducing the performance costs that came with that touch control camera. We wanted to reduce vertex counts, improve the LODs. We wanted to utilize the memory profiler where we could, just to help diagnose any memory usage issues. We wanted to refactor the vertex animations just because we found that it kind of affected the frame rate and the thermal performance. We looked into how DREDGE uses their terrains, but we also wanted to make sure that it was optimal for how it was running on mobile. And then finally, we wanted to just make sure that the scriptable render pipeline, or SRP, was correctly set up to work with all the shaders that were within the project. Next slide, please. Thank you. Yeah, so briefly talking about the Play Game Services package. For us, it was a critical thing to integrate for the Android port. Google thankfully provides a nice little package that you can import into projects if you want to do this yourself. But for us, we wanted to include it with authentication. So we needed this for signing in. PGS will provide a nice little prompt for players when they're going in so that they can log into their Play Game Services account. They implement it in a nice way that it doesn't harass you. So if you choose that you don't want to log in, it's not going to constantly pop up until you do. If you do choose to not sign in, you can do it at any later time. There's ways to do it via code. DREDGE was able to add just a nice little handy button so that you could log in whenever you were ready. Yeah, so sorry, I'm just reading my notes here.
Take your time. You're doing great.
Thank you so much. So one of the sort of things to be considerate of, though, is that to be able to sign out of the game, if you wanted to sign out of Play Game Services once you've signed in, you do have to do that in the separate application. That's just how it's currently constructed, but just so that you're aware. One of the other systems that we put in, as mentioned before, cloud save. So we wanted to make sure that players are able to sign in with their account, and if they do, they're able to have those saves across all of their devices. So the cloud saving system includes a pre-built OS level UI. So if you don't want to necessarily make your own UI, there is something that works or comes out of the box, but it's not necessarily ideal for every single project. So just you can decide and connect to the backend as you see fit. So the saves, the way that it works is that, if you save a game, it'll cache the data locally. And then once you have a stable internet connection, it will push it to the cloud. There's a pre-built in conflict resolution so that, if you're playing games on two different devices and you're saving them at different times, they will auto-resolve it based on when's the last time you played, or how much time have you played. So then that way, if you got a little bit further in one of your other devices, it can auto do that. That being said, if you find that that is not a great solution out of the box for you, it's easy to be able to go in and put in your own conflict resolution system. One of the things that we encountered, though, is that there are nice callbacks. So as a reminder, this is all happening asynchronously. So you can listen for if things break or if they don't work, but you'll get things for adding games or checking to see if games exist, but you won't get callbacks right now if you delete a game. So if that's something that is important to you, which it was for us, because we maintain a local copy of the saves just in case players decide that, hey, I don't want to be using the cloud save anymore and I just want it to be local to my device. We want to be able to maintain those saves. So if those are deleted on the cloud save, there's no information to say that. So there's a little bit more legwork involved to double check that that has been completed. And finally, for the PGS, we implemented the achievements, as we mentioned before. So you will need to be signed in to use achievements like you will with Cloud Save. There is a nice OS UI for displaying the achievements as well here. You can implement the incremental achievements if you want. So that's like the progression thing I was mentioning before. You can have hidden achievements, and all of those things can be managed from the Google Play Store console. So pretty simple to integrate, and it's all nice to have. There's some other things that come with PGS. So like there's leaderboards, there's friends lists, but because that didn't really match with what Blacksaw Games wanted for the PGS integration, we decided that we didn't need to include it.
Oh, okay. I saw those both on there, and I was like, I don't know how I can compete with my friends in this game, but I would like to. And I don't want to derail too much, but on the topic of achievements, in terms of Dredge, got them all. Every single one. I worked for it. That's how much I like this game. There is also like a very Pokedex style achievement to go through, right? You keep your logbook of all of the different versions of fish that you've caught, and I went through to get all of them. So not to brag, but shout out to all those achievement hunters out there. You know.
Well, now you're going to need to do it on the Google Play version as well.
I might have to. Yeah, I might have to do it multiple times now.
Awesome. So, all right. So I mentioned ADPF before. So Android Dynamic Performance Framework. That's a lot, but what this means is it's addressing a problem. So for us, for Dredge, thermal throttling was the problem. So what that means is that as the game is running, it'll start getting hotter and hotter, and then the operating system on your phone will try and reduce the amount of resources that app is allowed to use. So what that does is over time, it'll lower your frame rate. It'll kind of impact performance. And, that's not ideal. So what ADPF attempts to address is that problem. So if you look at this picture, we can see a couple things. So like the x-axis, the x-axis is the time in minutes. So we can see just a session here that was recorded. And then the y-axis for that blue line is just the frame rate. There's the other thing. So you'll see that yellow line. So those are thermal warnings or throttling. So you'll see that by 3 minutes, we're already at, it's 2, but it's at the top, which means that we're now thermally throttled, which is the operating system saying that, okay, this is no longer allowed to use as many resources as it is. So that's not ideal. So you'll see that temperature climb, you'll see the frame rate drop. We don't necessarily want that. We want to maintain as much of a smooth experience for the players as they're going through.
Yeah.
Next slide, please.
For me, my last job was a community manager on a mobile game. So living this mobile world is very, personal to me. And we have Felipe Gama in the YouTube chat saying, I thought thermal throttling only happened on PC. This is definitely a big component of mobile games. The game that I worked on made your phone run hot. And when it impacts performance, depending on the type of game, like Dredge has QTE style mini games, essentially, to try to catch each fish. Inevitably, you'll catch it regardless, even if you didn't participate. But those drops in frame rate and responsiveness, that makes a big difference in mobile gaming for sure.
Yeah. One thing that is notable in this graph, right, is that when you start your gameplay session, right, you'll start at in this case, it's an S23, and it starts at 120 hertz, right? So the app will run as fast, the phone will run as fast as it can on its native resolution. But then once throttling kicks in, right, it goes down to around, it's in the high 70s, isn't it? Like mid 70s.
I think it was about 75.
Yeah, about 75 frames, right? Which, you'd think that was great, right? Like it's still running like more than 60 frames per second. But you're in a thermal throttling situation, right? And it's only going to keep degrading from there, right? So although it's still faster than what you would normally consider good frame rate, which is like for a game, which is 60, you're actually not in a good state. Like with the phone, you're killing your battery life. You're literally killing the life of your phone, right? To maintain 75 hertz, right? So. Yeah. Shall I move on to the next slide, Alex?
Sure. Yeah. I mean, like one thing or one way I like to think about it as well is, if there are car people watching this, it's more like if you're redlining it the whole time, you can do that for a limited amount of time before it's just not good for view the vehicle. So this is the application redlining the phone. So that's not ideal.
I love a good analogy. Thank you for doing that.
Yeah, of course. So how do we address the problem with the thermal throttling? So we use ADPF. So one nice thing is that ADPF is now included with Unity 6. So you should be able to find it within the project settings. But for us, we were using a pre-Unity 6 version. That's just what Black Cell Games was using for this particular project. So that means that we just had to add the package through the package manager. So again, it's simple to follow, but it kind of let us integrate it. So out of the box, ADPF will provide two things. So there's an Android provider, which is just something that targets all Android devices. But then Samsung has also provided its own ADPF wrapper, which has access to a few more Samsung-specific items that you can kind of tack onto. But I believe it's also possible that if you want to make your own wrapper or provider, it's possible. Yeah, you just need to know how to access all the low-level Android stuff so you can read all the thermal information. But if you're up for it, you can theoretically do it. So for us, the ADPF functions by tracking the thermal states of the CPU, the GPU, and then what it does is it dynamically adjusts settings as it goes. So it uses something called scalars, which is like a 0 to 1 values to apply to graphical features, so that as it's getting hotter, it'll kind of adjust things down to make it run a little bit better. So some scalars can include the render resolution or maybe the shadow map size, how the anti-aliasing is being applied, any post-processing bloom, resolution, all this, all these different options. So there's a couple that come out of the box, but it's also relatively easy to make your own if you need to. So we did, which we'll touch on in a little bit. But generally what you do when you're making your own scalars is you say, how does this scalar impact the game? Does it improve CPU? Does it improve GPU? Does it improve how it's being drawn on the screen? And then that way it will pick things or prioritize items within those scalars that target systems so that things will adjust in a way that makes sense for you. So the base implementation is pretty straightforward, but it might be a little choppy as it's adjusting settings. So for us, it's a little bit about finessing just to make sure that it's meeting what Black Cell Games needed, what we needed. So it's one of those finessing systems as you get closer to the finish line. So for our implementation, though, we augmented it with something called device profile. So you can see it in the picture at the top where we're able to specify, okay, high, low, medium end devices, how does everything react based on the information that's being thrown back from ADPF. So this lets us, if it's a higher fidelity, if it's a better performing phone, maybe we want the resolution to not get super low, and we can prioritize diminishing frame rate. But maybe if it's a lower end device and the screen resolution isn't as important, we can maybe do that instead of changing the frame rate or in addition to. So we can set the bounds for particular devices. So that was really helpful for us. And it also made it really easy for Cerebral Fix and Black Cell Games to be able to go in and make adjustments as they saw fit.
Yeah. Alex, I want to bring in a question from Just Luis on the Twitch chat here.
Yeah,
and I'm going to paraphrase as well, but the options to kind of use high, mid, or low range devices, does that kind of allow you to be more broad instead of being so granular as to going into individual phone models and kind of tweaking and adjusting and seeing how those would impact?
Yeah, so for that high, medium, low, we just had this abstract idea of how powerful a chipset would be. So we just pick a number based on the devices that we had. Okay, this device is sort of within our high-end threshold. This device is within our low-end threshold. But the complexity with Android devices is that there are so many. And being able to kind of target very, very specific ones is almost unrealistic. Like, you need to be able to adapt to ranges of devices if you want to be able to hit as many as possible. So,
Sure.
yeah, I'm not sure if that answers the question, but
I will nod on their behalf and assume that it did. It
great.
sounds like it did to me, but I don't have the technical knowledge. So,
Well, if they come back, I'll follow up if we need.
gotcha. Copy that.
Cool. So yeah, so like one of the complexities that comes with ADPF though is how to debug it. So there is a very nice profiler module that's included with it, so that, you know, when your device is connected to the profiler, you can watch it as all of the settings adjust. But you know, if we're passing that information to sorry, did I go too far, Joe? I saw those.
Oh yeah,
slide switch.
that's okay. That's okay. Sorry.
Okay, sorry. So the complexity with that though is that the QA or anybody who's doing testing on the devices may not necessarily have access to the profiler, or there's a consideration when connecting to the profiler that it adds a bunch of overhead. So like, you have visibility on things that are happening, but just the act of measuring it adds additional overhead. So in an attempt to, one, make it easier for QA to tell us what's going on, and to make sure that it's as you know, reflective to the final product as can be, we put in something called this ADPF debugger. And this allowed us to display the current state of ADPF. So it's just like overlaid on the screen. We had QA send us any screenshots with issues with that included, because there were instances where, you know, the original implementation that we put in had render scale and adjustments on the resolution, which competed with each other, which meant that, you know, something that was like, let's say 1080p was accidentally getting down to like 480. So this debugger helped us really understand particular device ranges that were encountering that issue, and we were able to resolve it much easier. Yeah. And the other thing is that we wanted this to be easy to use, again, for Black Cell Games and Cerebral Fix. It's a nice little prefab. You drag into the scene, it handles everything on its own. So if it's in there, great. If it's not, great. It just makes life easier for us when we're getting feedback from QA for things that are like, hey, this looks weird. It doesn't make any sense. Yeah. Next slide, please.
Before we move away,
yeah,
Alex, I wanted to bring in a question here from Mr. Awesome. And it might be something that you don't have the answer to, and that's totally okay. But they inquire, doesn't Google publish the device statistics so you can better target that market that has a device that can run your game? Is that something that you're familiar with through the process that you went through to find that information?
So I'm relatively familiar with that. You can absolutely do that. Like, if you want to target specific devices, all the more to you. So because we don't know like what devices, the low end devices people are going to be targeting, or the high end devices people or that are going to be coming in the future, we kind of have to keep things broad so that it can just run in as many things as physically possible. So that's why it kind of has to be abstract. If you're targeting specific devices and you need it to run specific ways, or you're getting issues on those particular devices, absolutely, it's very feasible to change things to adjust around that.
Yeah. In my limited experience, again, more speaking to people developing on mobile, that specificity becomes even more useful. And Alex, you touched on it, but when you're seeing bugs, is there a trend? Oh, this bug is creeping up for people only on this specific device, then kind of being able to dive in and explore those specificities becomes a lot more useful in those moments as well.
For sure.
Yeah, there will also be in this presentation, we're going to talk about the VK Quality Toolkit, which actually will keep like lists of device profiles, right? So for very specific devices, right? So yes.
Cool. Yeah. So in terms of like how ADPF impacts the performance, so again, we want to make sure that things are running as smoothly as possible. So if you notice the chart on the left, that's the one that we saw before, where it thermal throttles in 3 minutes. Not ideal. The chart on the right with ADPF implemented with this like device profile, we start at what we want to be running at, 120 hertz. Great. So as that's happening, well, the system is starting to notice, hey, things are running a little bit hotter than what we want. So let's start changing the settings so that it starts reducing that climb. And then eventually it'll just say, okay, let's just run it at 60 hertz. We're comfortable at 60 hertz on this device. In this case, it's the S23. And you can see that it just kind of stabilizes. So not only does it delay when the actual thermal throttling would happen, you'll see here that it never even hits it. It just hits a plateau and it says, okay, this is a comfortable range for us to be sitting at for the rest of this session. So yeah, it's very handy for us, and it made it so that every device is going to be different. Some devices aren't going to benefit as much from this, but again, the way that we constructed it between high and low end devices hopefully makes it so it's as broad as possible and everybody's experiencing as a smooth experience as possible.
Yeah, what's really neat about ADPF when it's active as well, like when we were testing it ourselves on a variety of devices, was that the phone never really got hot. Like you could comfortably hold it, right? So that that's great, right? Because that means that long term wise, yeah, your phone is not reaching a state where it is slowly destroying itself in order to play your app, right?
Exactly. Cool. So, you might have questions about, okay, how does it impact visuals? So for us, we aim to have as little impact as possible. So change things around LODs, which we'll touch on a little bit later, but we wanted to maintain high visual fidelity. So if you look on the left, that's no ADPF, and on the right, ADPF. It should be almost it'll be very difficult to tell the differences. And the idea is that as it's changing, that it's happening in such a way that you can't necessarily notice. So, things like the reflection camera will turn off. That might be the most noticeable, but the intention is for it to be looking as good as it can throughout the experience. Next slide, please. Cool. So now let's talk about VK Quality Toolkit. As Joe mentioned, I'll try and pick it up because I know I'm kind of dragging this out. I want to make sure that there's time for Joe and questions. So VK Quality Toolkit, what is it? It's a plugin made by Google again that contains a list of devices that support Vulkan and those that should be targeting OpenGL ES. So what that means is that there are some devices with some combination of hardware that makes it so that Vulkan would be unstable. And then in this predefined list, if it's okay to run Vulkan, it'll do that. If it's not, it'll fall back to OpenGL. So makes life very easy for us. It's just a plugin that you throw in. You make a few adjustments in a Java main activity, and you're good to go. It's all kind of explained very thoroughly in that link that Google provides. One thing to note, though, is that the VK Quality Toolkit plugin, the functionality is now built into Unity 6. So you have those exclusion and inclusion lists within the project settings for Android. But if you're using anything previous to Unity 6, you can, again, just add the package, make the little setup, and everything's good to go. For us, it was important to be able to see which was being targeted because, each will act a little bit differently, which we'll get into in the next slide. VK Quality Toolkit will spit out the log that says which one it's running on. So for us, when we were using URP, there were some differences in how the shaders were being handled between OpenGL and Vulkan. So for DREDGE, the MSAA was poorly supported on the devices that were forced to use OpenGL. So, we can observe in that top right image, there's like a little bit of an outline effect on the water. And in the image below that, you can see that there are like big blooming artifacts, again, related to the MSAA integration for OpenGL. So one of the ways that the way that we resolved it was that we used the ADPF so ADPF, we had it so that it slid between MSAA and different anti-aliasing techniques depending on the performance of the device. So we were able to integrate something in there that it said, hey, if we're using OpenGL, just make sure that you're not using MSAA because, otherwise you're going to experience these issues. Next slide, please. So the touch controls, let's get into it. Joe, next slide, please. Thank you. The extra camera overhead. So every time you add a camera into the scene or into the game, it'll add around millisecond of overhead. So for us, if we have the game scene camera, we have a reflection camera, adding an additional millisecond, it's hard to justify. So the way that In Control operates is that it includes a orthographic camera so that it can see or project your inputs onto the existing canvas system, which is great. No complaints about that. Our main complaint is around the camera existing at all. So we needed to remove that overhead. So In Control still works and allows those touch inputs. And we wanted the UX team, which is Cerebral Fix, to be able to focus on just that. We don't want them to worry about, okay, I got to manage all these cameras. I got to worry about all these things. So our solution was to implement command buffers for this. So the graphics command buffers let us manually queue render information that can be injected into the scriptable render pipeline, so SRP. And then we have like a little example of how it works there. So for us, we get a command buffer from the command buffer pool. We set the camera properties. So like we are able to have a camera in the scene, disable it, still retrieve all of its information so that we can apply the view matrix, the projection matrix, and its positioning. So that was very handy. But then we clear the buffer, we queue up all the renders, which is like us searching for all the things that are meant to be drawn. We put it onto a render texture, and then we queue it up with execute. So the render texture solution, though, what it does is it shifts the cost. So we have that 1 millisecond that we removed from the CPU time, and then we essentially convert it into memory cost. So there's pro cons to all these things. Nothing's free, and this is sort of an example of that. Next slide, please. Oh, sorry, you're already there.
Joe's out here predicting needs, Alex.
He's incredible. He's incredible. So one of the benefits for us was that the command buffer solution for this didn't need per frame updates. Because it's UI, one, it doesn't need to be running every single frame. Two, it doesn't, like, players aren't interacting with every single frame. So one of the exceptions to that was the joystick UI. So at the time, DREDGE implemented the little UI element that just made it so that it was a little bit choppy. But again, if we can render it once every 3 frames, once every 4 frames, we built a system that let them kind of adjust how that went. The other thing is that you can change the scale of the render texture. So if it's 100%, on a 16 by 9, 16 by 10 resolution phone, that takes up a lot of memory. So we can reduce that and still maintain some visual quality. So that's great. Next slide, please. So the command buffer, had some issues that we had to work around. So again, OpenGL had some issues with the command buffer. We saw it specifically on some Pixel 6 devices, but there may be some other devices that experienced it. But essentially, it meant that the depth buffers needed to be cleared. Otherwise, we saw these artifacts that you're seeing here on this image. Cool. Okay. Memory profiling. So next slide, please. Yeah. So for us, this was an essential thing to be able to find some things to optimize. So one thing that's super cool, if you're not already aware, so you'll notice if you're on any older versions of Unity that you're limited in the version of the memory profiler that you can use. So if you try to install 1.0, it says, oh, you need 2022. But there's a way around this. So for example, DREDGE used Unity 2021, but we wanted to be able to get the newest version of the memory profiler. So what you can do is create a blank project with the newest version of Unity. You add the newest version of the memory profiler, and then you can just connect your device to it and get those new captures. So it comes in handy for us because we're able to see more detailed information around the assets and more easily compare 2 different memory captures so that, if we're changing how things are compressed, we can see, okay, like A/B comparison, okay, before it was this and after it was this, and here's the differences between those changes. Next slide, please. So for example, here's one of them. So originally when we were doing the Android port, we were targeting ASTC 6x6. So when we're reading the 6x6 or 8x8, those numbers are how far from a pixel in pixel range should be used to compress that image. So 6x6 means that it is a higher fidelity image. 8x8 would mean that it's more compressed. So originally we were using 6x6. Like this provides significant improvements from what the default ETC2 would be, which is more broadly supported but is not as performant. So we decided to go with ASTC 8x8, which I think due to the art style made it so that the visual changes were almost invisible, but that made it so that like the memory footprint around textures was reduced by 54%. So going 6x6 to 8x8, that's a huge increase for us. So that's what we want to see. So we tried. Sorry, so we're still on the other slide, Joe.
Sorry.
No, it's all good. It's all good. So where possible, we worked with the teams to figure out those non-power of 2 sprites. So anything that's not power of 2 doesn't work well with the GPUs and how it wants to compress it. So we tried to kind of aggregate them into as many sprite atlases as possible. Wasn't possible for all of them. Some of them required to needed to be independent for shader usage. But we made as many sprite atlases as we could. The other aspect, so now we can go to the next slide, particle pooling. So this is another thing that we spotted within the memory profiler. So we noticed that all of the fishing locations in the game contain multiple particle emitters, and all of them, I think they totaled beyond 3,500 total particle systems, which took up 60 megabytes of memory. And for particle systems, that's a lot. Ideally, you should be aiming for less than that. So this was a prime target for us to improve. So other things to consider is that having all of these objects, it affects the boot time because it needs to load all of these things and it needs to add them all into the scene. Sorry. The other consideration is that, in an individual play session, the chances of you seeing every single particle system within the map, very unlikely. In my experience playing the game, you go from the center and you kind of do a couple chores between a specific island or zone or biome, and that's pretty much it, which means that, 60-75% of these particle systems that have been loaded are never even interacted with or seen. So again, prime candidate for some optimization. So we worked with Black Salt Games. They implemented a particle pooling system, which pre-allocated a collection of them, and then as the players get close to them, they're able to kind of activate, deactivate, and then get recycled. So we were able to reduce the total system count by 41% and reduce memory cost by 45%. So again, all great things. That's going to be it from my end. I'm going to pass it off to Joe to talk about more graphical things.
Thank you so much, Alex. Yes.
Great job, Alex, by the way. Fantastic.
Thank you,
You guys did great. And the two of you working in tandem here, just predicting each other's needs back and forth. Joe on the controls, Alex on the knowledge and the hosting. You guys are crushing it. Keep it going.
Sorry for jumping the gun a few times there, Alex.
No, it's all good.
All right. So, yes. So let's continue on with optimization. So we're going to talk about the SRP, Scriptable Render Pipeline Compatibility. So, we need to ensure that all the game shaders were compatible with a scriptable render pipeline, like the universal render pipeline. Now, this would allow the graphics system to fully take advantage of graphics pipeline optimizations that exist in URP. Now, fortunately, most of the shaders in Dredge were already using shader graph. So in a case like that, ensuring SRP compatibility is very easy. Just, go to the shader graph, and just set the shader's target to universal, and you are done. So, however, a handful, notably UI shaders, were written for the built-in render pipeline, so they were still in Shader Lab, in CG. So we needed to ensure that all the game shaders were compatible with URP. So now, in brief, right, the conversion of the shader files to SRP involved the following changes, right? The first is declaring a declaration of the universal pipeline tag for your render pipeline, replacing the Unity CG.cg Inc. And replacing that with core.hlsl. We also needed to observe Unity HLSL conventions, primarily those with using varyings and the attribute structs. Now, also, where possible, ensure that your properties are going to be in your shader properties are included in cbuffer, so that would make them SRP batchable. Now, also note, right, that certain macros in CG don't actually have equivalents in HLSL. So in those cases, you're going to basically have to create a custom function, likely within the shader, that recreates the macros functionality, right? So the example we have here is in CG, you have the Unity get2D clipping macro, right? Now, what is that? It's a helper fragment. Helper function in Unity. In UI fragment shaders. It retrieves a value representing whether a pixel lies inside or outside a predefined rectangular clipping region. If the fragment is inside the rectangle, it's rendered. Otherwise, it's rejected. So as mentioned, it's in UI elements. So in HLSL, what we did here in this example is that we used the step function to essentially threshold whether a position falls inside a clipping rectangle. And then it returns a 1 if it is, and 0 if it is not. So therefore, we recreate the old CG macro in HLSL. Now, one nice benefit of ensuring SRP compatibility is that you can get performance gains, right? So the example I'm using here, like in the image, is the time of day shader. Now, this is actually a rather important UI element because it is always on screen, okay? So, and actually, that was one major reason why the UI shaders also had to be optimized for, and ensure that they needed to be SRP compatible, was because they were usually there all the time, right? So, now, it is on screen always. We see an 87% improvement in performance simply after converting the Shader Lab shader from CG into HLSL. So let's talk about the Vertex optimization workflow. So this workflow applied to all major mesh elements like towns, docks, ruins, any other landmarks in the game. Visually, we needed to deal with perceptible popping as the LODs transitioned. As Alex mentioned, one of the issues we saw was that a lot of geometry was quite heavy, and then when they popped onto the LODs were very light, and so you see like a noticeable a switch, right? It was actually very jarring, right? In this case, we saw a 23,000 triangle to 6,000 triangle switch, right, between LOD 0 and LOD 1. So a little bit excessive, right? And the way that they were authored mattered, actually. The original LODs were made using a commercial decimation package. I'm not at liberty to say which one. And the LOD vertex counts, they differ drastically, right, as a result. So that had an art requirement at a slight performance cost, right? We needed to basically create smoother transitions, which meant that the LOD vertex count needed to decrease more gradually. And it also entailed actually creating more LODs, right? So that's where, you're basically trading, visuals with, for performance, right? Like as cost-wise. Now, like as mentioned, it would entail more memory, but it was worth the visual improvement, right? So one thing I wanted to take note here, right, is that when you are optimizing for mobile, it isn't all just about, let's get as a highest frame rate as much as possible. Let's reduce, vertex counts as much as possible. It's a give and take, right? Within that tiny little screen, right, you need to make sure that every single pixel that's rendered is worth the performance cost, right? And sometimes, you might want to, put a little bit more cost for better visuals where it's worth it, right? And in this case, like, making the player experience more smooth and less jarring is well worth it. So why did we decide on Houdini? Well, the very large majority of heavy meshes, they were actually combined meshes, right? So a town, for example, would be composed of 100 or several hundred sub-meshes, right? So yeah, a single mesh would represent a collection of all the discrete submeshes that made it up. Many objects in the town by itself did not respond well to LOD decimation, mainly because each of these sub-objects, right, when looked at individually, they had a lot of geometry issues. They were not watertight. They had internal face intersections. They had a lot of surface discontinuities, which a lot of decimation packages would just break. It would I would literally get buildings that would the decimation package would focus on like the large structures, like and make a building into a pyramid, and it would ignore like small objects, like which is it would ignore like lampposts and like little barrels, right? And it drove us nuts because it's like there was no way to control that. Now, Houdini was desirable in this case because you could actually use Houdini to filter sub-meshes based on their size. So gameplay-wise, we had a couple of requirements, right? We needed to preserve recognizability at distance, right? So the silhouette of the town mattered, and it mattered when you went to far distances, right? So again, so authoring smoother LODs, that was another point in that matter. Town windows and lamps, since they needed to be visible, especially at nighttime. So this actually had real gameplay relevance. Like when you're in the midst of a storm at night and you see the faint flickering of lights of a town in the darkness, that could mean your survival, like in gameplay, right? So that needed to be preserved. Unfortunately, windows and lamps are small items, right? And so we needed to be careful about how we filtered those particular objects out. But in general, the algorithm was that we identified all the connected geometry, right? In this case, we selected connected points. A connectivity attribute in Houdini, this is called a class, is generated for each connected set. So if you look at the image, excuse me, I was coughing too much.
You doing okay, Joe? If you need a sip of water, you take your time. You listen. Yeah. You're going a mile a minute, and if you're speaking to anyone who can sympathize and understand that with you, it's me. So you've been monologuing. Oh, Don't worry, that takes its toll. If you need help, Alex and I, we're here to carry that slack. So you just let us know.
Here in San Antonio, it is it's pollen season, so I'm being affected by that.
Yeah.
Yes. So. But anyway, yes. If you look at the image, right, you'll see the town represented in this shaded view, and it's got multicolors on them, right? So each colored region represents a discrete piece, right, or a set of connected points. So those sets are basically an attribute that Houdini can work on, and then you use the measurement node in Houdini to basically what that will do is that will draw a little bounding box around each of those sets of connected points. And you can use this, right? Because this bounding box will give you a size, a scalar, right, of a size that you can then threshold to, right? So you could then you could literally then separate out smaller objects based on size. It can be filtered out. Now, however, if we were to just apply that algorithm, this would actually kill off all the windows. And we actually discovered that the first time. We didn't realize that when we were that windows were actually a gameplay requirement. And so our higher LODs didn't have windows. And BSG came back to us and say, we can't see anything lit up at nighttime. What's going on? It's like we realized, we called out the windows, right? So yes, windows needed to be they needed to be preserved. But how can you, if you have a filter that filters based on size? Well, so to isolate, we needed a second algorithm that worked, worked previously, right? So we needed to isolate the windows, right? And so the way we did that was we selected any of the points that the mesh's UVs were hit by emissive pixels. Okay, so basically there was an emissive channel like in the material, and there was an emissive texture, right? And so any UVs that were lit, right, by emissive pixels that greater than 0 in color, greater than black, right? They would basically be selected, and then the associated vertex to those UVs would also then be selected. Now, this information, right? This emission information was stored in the mesh through a temporary data channel, right? Houdini offers a whole bunch of them. We needed a vector, and among the built-in data channels that it includes was, I believe it was velocity, right? You could create a custom vector data channel, right? But that was, unnecessarily. We just needed something that could store vectors, and so we did just that. Now, once the emissive points are selected, we then use the connectivity nodes to select its connected neighbors, right? The idea here is that, if one point of a window is lit by an emissive channel, then because windows were discretely modeled, just select the connected points and it would automatically select the window. Now, the reason why you would do this is because the reality of it is in the game, the emissive textures were actually very small, right? They were very low resolution. And so it was possible for a vertex, right, or rather for a UV to actually fall partly outside an emissive pixel, right, because of the low texture resolution. So selecting by connected points ensured that the entire window was selected. So once you have that, reverse the selection, and then you could call out anything that had a black emissive channel, right? And then once you have those two divergent streams of just the windows and poly-reduced meshes, right, for the submeshes for the town, right, or for the big mesh, you just combine them, and then that is your LOD. Yes, and so
Joe, sorry to interrupt. I just wanted to give you a heads up. We got about 15 minutes until we hit our aim time. We got some flexibility, so just to kind of give you that heads up. Before we move off of LOD stuff, we have Mr. Awesome in the YouTube chat saying, "Isn't auto-generated LODs a new upcoming feature for Unity? Is anyone aware?" And the follow-up then, Joe, I'm glad that you have some insight on this. Was this the result of the dogfooding that the team has done on these types of projects?
What you're actually mentioning, which is basically mesh LODs, I unfortunately can't actually speak too much about it, right? But it was actually happening in concurrence with what we were developing.
That's
right.
Very cool.
Oh yes. So this one was actually a very customized solution specifically for BSG, right? Simply because of their particular circumstances, right? Of using combined meshes, right? That had little submeshes, right? And so Houdini was very useful for that.
Awesome.
Now, in terms of auto generation, the wonderful thing about Houdini is that it's basically a flowchart, right? That can be scripted, right? And so that's what we did. We would basically auto-generate as many LODs as we wanted, based on one or two poly reduction scripts. So now, concurrent with the work on ADPF, we wanted to see the effect of vertex reduction on thermal performance, right? In this graph, we measured battery temperatures, right, before and after vertex reduction. So we noted big, smoother LOD transitions, right, which was, of course, what we wanted, and recognized and recognizable landmarks. We saw them even at nighttime and with fog, right? So we traded GPU expense for memory, right? But we got both improved thermals and better visuals, right? So that's a win. So now we're looking to optimizing the terrain system in the game. Now, Unity terrain is actually used to represent the underwater environment in Dredge. It does visually contribute to Dredge's art style to give a sense of the depth of the water, and it has gameplay uses too, right? Because creatures can hide in nooks and crannies in the underwater environment, and based on your camera angle, you could actually see that, right? Like if the water is shallow enough. In mobile, however, terrain has a few issues, right? One, it's very expensive with a notable impact on draw call usage. It just skyrockets, right? Plus, many of its features, like the ability to paint multiple splat textures, they were not really actually being utilized for the expense that we were incurring. And we discussed with BSG about replacing the terrain with a multi-mesh approach, even a tiled multi-terrain approach. However, the time and work requirements to implement them, they proved to be, infeasible, right? And by and large, they were actually even less performant. So instead, we focused on optimizing what we already had. And we discovered that pixel error had a very big influence on the draw calls. So this ended up being the most elegant solution, because pixel error was only truly useful in situations, where you had multiple terrains that needed to be blended seamlessly together, right? That's where pixel error actually mattered. But since Dredge only used one single terrain, this pixel error value, we could just set it as high as we could go, because we weren't worried about terrain stitching, right? So in a single terrain context, pixel error kind of behaves similarly to dynamic tessellation. So we could get away with higher pixel error values because, one, the terrain was also underwater, and the water shader distorted the terrain, so there was no need for accurate tessellation fidelity. I mean, like if the triangles are all going to be distorted anyway, right? And secondly, and more importantly, there was no true gameplay requirement that necessitated high terrain detail, right? The camera never really went underwater, right, for really any period of time, right? Now, another optimization we looked at was the water system itself, all right? Dredge used a tiled water plane system to represent a vast ocean, right? These were extensively tessellated water planes, right? Because there is wave displacement effects that Dredge used, and it was implemented in shader, right? But it required highly tessellated triangles. Now, however, we noticed that the LOD setup of the water planes, as it had the furthest LOD, right? Essentially your horizon line, right? Each plane carried 576 triangles, which was crazy. So basically, you could have 10 of these. It was actually a dozen of these water planes just to define your horizon line. And yeah, you'd be breaking 5,000 triangles right there. It was kind of ridiculous. And further, did we actually need those triangles? Well, the shader had a wave distance fade mask property. And what it did was it would actually attenuate the wave height based on distance. So when you went to the horizon line, there was no wave attenuation. There was no wave displacement effects at all, right? So there was no reason to have that many triangles. And so we actually, we had a limit of LOD, of 3 LODs, LOD0, LOD1, and LOD2 for the water planes. Well, we extended that by putting an LOD3 of a water plane that just had 2 triangles instead of 576. And so this one reduced the horizon line to a much more performant triangle count. The vertex to fragment ratio was much more evenly distributed, so it improved GPU performance, and it also pushed the LODs further closer, right? So that means that your LOD1 and LOD2 didn't have to tessellate. They didn't have to carry tessellation farther out, right? Because they now got pushed closer. And so finally, I'd like to actually talk about Vertex Animation. This actually proved to be a big deal. Where did we use Vertex Animation in Dredge? Well, it was used in trees and in foliage, right? So the islands in Dredge have a variety of flora in them, anywhere from distorted trees to lush pines to birch trees, right? And all of them used shader-based Vertex Animation. And these were expensive on mobile. And as we'll see when you do tests, they actually caused thermal issues as well. The trees of various species were everywhere on most islands. And fortunately, they did have LODs already implemented. So that's great. However, vertex motion was on all the time, on every LOD, all the way to the maximum culling distance, right? So that was a little excessive because in gameplay, you really could not see the trees vertex animation on their further more than 200 meters, right? That's a stretch. On mobile, it was more like 50 or 60 meters. So yeah. So our solution was as follows, right? So we had an LOD0, right, which uses vertex animation just as before, but we introduced an LOD1 that uses the exact same mesh, but it received a shader variant with vertex animation switched off, right? And then the higher LODs, they used lighter meshes, but we used that shader variant with Vertex Animation off. So now Vertex Animation was limited only to LOD 0. So this was cool. It worked, and actually our performance really increased. Like it was so much better. However, we did notice popping when LOD 0 transitions to LOD 1. As you can see here on the lower right image, the tree would be swaying until LOD 1 appears. Then the tree would instantly pop into a stationary pose, right? So to fix that, we implemented a fade off that lerps the animation amplitude down to 0 right before LOD 1. So it was basically a shader property that that multiplied to a distance, camera distance to the vertex. So that would, and that gave us a slope that we would attenuate down to 0 before LOD 1 gets reached, right? So that was cool, right? However, it did come with some issues, right? One issue was that when ADPF started to, change LOD bias, because that's what it would do, right? That was one of the optimizations that we wanted. We wanted the LOD biasing to be closer to all the objects, if ADPF is on. Well, the problem with that is what you can see here, right? Is because the fade-off value was static, there was often a case where the Vertex Animation would attenuate, but it wouldn't be quite 0 yet. And then LOD 1 because it pops in because it's now closer in. And then as a result, it became instantly stationary. You can see that on the upper right image, right, in the stellar basin, right, where the fade off wasn't completely 0, and then LOD 0 switches to LOD 1, and then you still get that perceptible pop off. All right. So let's look at the graph, right, to see this in a bit more detail, right? So in red, the graph is in red and in green. So the red arrows here mark the distance from camera at which the LOD transitions to a higher level with ADPF off, okay? So the red curve shows the normal vertex animation when ADPF is off. Note that the curve is tuned, so that vertex animation is 0 right before the first LOD is reached, okay? Now, so this, under normal circumstances, it beautifully prevents the popping artifact from appearing, right, from when you go from LOD 0 to LOD 1. Now, you look at it in green, right? So, I'm sorry, if you look at it in green with ADPF off, if that fade off is still static, right, there will be a chance that, LOD 1 is reached, but the vertex animation is still not 0, right? And then you will see the popping. So our solution to that was to basically expose a global float for the shader, right? And take, and basically ADPF basically passes an LOD bias, its biasing value, and it passes it as a property, right, to control the shader, right? So, so look at the graph in green, right? So this is the same shader behavior, but now with ADPF on, So like in the red arrows, the green arrows mark the distance from the camera from which the LOD transitions to a higher LOD level, but now ADPF is on. Now, notice that the LODs transition closer to the camera, right? Now, in the red graph, if the curve were to remain unchanged, you'll see the popping because vertex animation is not quite 0, right? Now, the green curve, however, shows the effect of ADPF's LOD bias scalar controlling the slope of the curve. So in this case, we pass ADPF's LOD bias into a set global float into the tree shader graph. So this global float multiplies the vertex animation output and attenuates it faster towards 0 if ADPF is active, right? So I also added an additional tweak to an additional parameter to account for size or species of tree, right? So those had different values for different trees. And so, yes, what this meant was that once ADPF is active, it could still account and control the attenuation slope, right? So the result of this is we still retain animated trees, but they are now much more performance friendly, right? LOD distances are still tweakable, and you can still easily balance performance and the visuals. And ADPF can still preserve vertex animation without danger of breaking it between LODs, and it's controllable by the LOD bias scalar. And because of this, it also respects device profiles, right? So So different devices can have different attenuation slopes, right? It really depends on the device. So what have we learned from all this optimization work, and what are the main takeaways that can be applied to your own projects? So one thing we've learned about this is that controlling thermals is paramount, right? And one of the biggest priorities in mobile. It isn't necessarily that you want to burn your users' hands, although that really helps, from a user retention point of view. But thermals are, a hot phone is a symptom of how a phone is attempting to play your app without shutting itself down, right? It's a danger signal, really. As Alex mentioned, it's like having your car redline all the time, right? So ADPF is a powerful tool to balance and optimize your thermal performance, but maintain your visual quality, right? So that's a big takeaway there, right? Secondly, you take advantage of URP's optimization features, right? So exploit shader batching as much as possible. Ensure that you have SRP compatibility on. Now, on mobile, lessen the amount of data going into that Vertex pipeline as much as possible, right? You have a smaller screen, right? Generally, right? So as a result, you need to ensure that your vertex to fragment ratio on your shader, right, is optimized for mobile, right? It does no good. You're going to have performance decrements if you're for a single pixel, you're having a lot of vertex, vertex pipe is being flooded with a lot of triangles. It absolutely makes no sense because they're all rendered to the same pixel. In fact, towards the horizon line, right? A lot of things render to pretty much at sub-pixel levels, right? If you're talking about vertex throughput. So employ memory management strategies as much as possible. Replace textures with shaders if you can, but be aware that there is a relationship between processing time and memory, right? And you want to make sure, okay, where are we spending our expense, right? And as we mentioned here, right, it's been brought up a number of times. A lot of features that we've implemented for DREDGE, they will come with Unity 6, right? So yes, indeed, right. So full integration of VK Quality being one of them. Vulkan improvements like split graphics jobs, right? And of course, the Android Dynamic Performance Framework, being integrated by default. Okay. However, we do give you a choice, right? You need to enable it if you really want to use it. But, honestly, in mobile, it's indispensable. Like it's the way to at least save your phone. So, yes. Thank you so much to Black Salt Games, Cerebral Fix for a wonderful IP, and they were a fantastic client to deal with. I hope we can continue working on projects with those guys in the future. Thank you to Google for VK Quality Toolkit, for ADPF, wonderful tools to use for mobile, and of course thanks to my team in Unity as well as USP. It's a bunch of great folks to work with, and so yes, and I think I'm at 1 minute 30. Oh, sorry, 1 hour 30. All right, so
basically dead on. We'll take a couple of questions because we got some time. But Chad, please help me in giving big shout outs and big thanks to Joe and Alex here because this was an incredible presentation. We had a comment. Nick Dawes says, this is a great talk. So many advanced optimization techniques. Hope that we can finish or re-release the GDC vision. So I'm glad that we got all the way through it. Thank you guys so much. You guys crushed it.
Yes.
We'll take a couple of questions, things that we already have, because I know we are a little bit tight on time here. Noise Crime on the YouTube side asked very recently, are some of these improvements being backported to other platforms that the game runs on? Obviously, you go through these optimization practices. It would make sense to further optimize the game in other platforms. Do you have any insight into whether or not they took these into consideration and going back to the other versions they've created? Also, obviously, that's not the choice that you guys get to make, but if you guys have any insight on it.
Yeah, so this is a question relative to DREDGE and Black Salt Games, correct? Not just like Unity and some of the tools?
Yes.
Okay, so yeah, so like when we were doing these optimizations, I think there was 2 different avenues that we were kind of focused on. One was just like Android specific things, so like that's where ADPF and like PGS, Play Game Services, comes in, which are going to be mobile specific. Like the LODs that Joe was working on Some of the memory improvements, those I believe, so those are what we considered general optimizations, and I believe they're intended to be kind of backported into the other platforms. Because there were other things that we touched on around like UI and other systems for like loading. So I believe, I haven't talked to the Black Salt team to see if they did, but we presented them with the opportunity to do it.
Oh, cool. That's awesome.
Right.
Great to hear.
A lot of the content related optimization, right? Like LODs, right? Like, so the LOD systems were like, it was basically, auto generated by Houdini, right? And so that is platform agnostic, right? That will, those optimizations will then carry on if they wanted to do a Mac OS or a iOS port.
Awesome. We had another question from Weekend on the Twitch side here about the controls. We talked about touch controls and optimization earlier in the stream. They ask, with regards to the controls, Dredge was originally made for a controller / mouse and keyboard in mind. Did you do anything specific to make the touchscreen controls more compelling, as you don't get the same tactile feedback on a touchscreen?
Unfortunately, I don't think we can answer too much, only because that was more cerebral fixes, the things that they were working on. So like in terms of usability, like a lot of the systems are interchangeable. I think there was a couple things that needed to change, but yeah, in terms of like any changes to user experience, that would be between like Black Salt Games and Cerebral Fix work hand in hand to make it as usable as possible. They spent a lot of time and a lot of testing to get it so that they were comfortable. And I think that speaks to the quality of products that Black Salt Games wants, and that they were very focused on making sure it was exactly what they needed, and they weren't rushing it.
Yeah. We've got time for one last question here. I want to bring in from Harry Alasavakis on Twitch. Said, did you find that mesh merging helped a lot with performance? Was there any balancing between batch count and vertex count of a single mesh?
Yes, there was actually. So one thing so for the towns, many of them basically, the whole reason why the BSG merged these meshes was for to ease batching, right? For example, now the wonderful thing is that the SRP batching, right, was used for these towns because they were all essentially using the same shader, right? And so yes, we had some considerations for ensuring that that we had to make sure that the town was actually using a single shader, and all of them were. So that way, they would go through the pipeline, the SRP pipeline, optimally, right? Like, how shall I say? So we didn't do any, reassignment of materials and putting in new shaders for the towns, because it was, it wasn't necessary, and in fact, in this case, it would actually work against us.
I know I said that was our last one, but I want to bring in one more from the Legend the Bull. The Bull's here at every stream, always keeping the chat light and happy and welcoming in new people. It's fantastic to see. The Bull asks, how do future updates work once you have done a port? Is it up to the company to release changes specific to each platform, or is there some sort of pipeline to push it out with each build? So I think if I can jump off of that as well, what's the relationship with USP in these individual studios after you finish the initial port and release? Does it continue? Are you guys continuing to be involved, or is it their responsibility? Do they take the ball and run with it from there?
So I'll jump on this, Joe, and then if you have any thoughts,
Sure.
just let me know. But in general, I think we want to equip the teams, the clients like Black Salt Games, with as much knowledge as physically possible. We want to make sure that they can operate independently, but if they want help and they want to come back, they can. In terms of like being able to build the pipelines for each platform, that's going to be team and game specific. And in their case, they were making builds for each of their platforms as they were going, and it was more manual. But I've seen projects where they'll make an update for everything and they'll build out different, like all of the different EXEs or APKs or what have you for each specific platform.
Joe, anything to add?
Yeah, so just to add to what Alex is saying, yeah, absolutely agree. USP, we as mentioned, we do custom solutions for our clients, right? But as much as possible, we devise these solutions, and they work hand in hand with us. It is very much a collaboration, right? And we work towards a solution that they can use independent of us once the client engagement ends, right? So that way that sets them up for future success, right? So that they can maintain the platform as much as possible, right? And it's actually it's paid dividends for us. We've had actually clients that yes, we've set them up, right? But then sometimes they would come back to us, right? Absolutely, right? For perhaps to work on another project, right? Which is obviously great, right? So yeah, it's something that once the relationship, like once the project is done, right? It doesn't really end. I mean, we're not their tech support. On the other hand, we're not their tech support, right? But on the other hand, we want to set them up so that they can run with the tools that we've helped them develop, right? And they can maybe add on to it or keep going, right? Like with their product development cycle.
Yeah. Fantastic insight. Thank you both. Before we send you off, again, another massive thank you. Joe and Alex, both. Thank you both for being here, for sharing all this insight, for adapting this, for working alongside us. I'll send you off with this final comment from Noise Crime on YouTube. Said, this was a great presentation, a perfect blend between providing high and low level details on optimizations. You guys both crushed this. We saw a lot of positive feedback, a lot of curiosity in our community as well. So thank you both. And Unity community, one last time, please give it up for Joe and Alex. Don't go anywhere. I'll pop back in to say hey and check in with you guys in just a moment. But again, thank you guys.
Sure thing.
All right, Unity community, just you and me now. We will be signing off in just a moment here. But before we do, we have a couple things for you. I just put a link to our survey in chat. We just want to know what's something that you want to learn. Maybe I can go and find someone that can help teach it, and we can do a fun interactive live stream to give you that information. As always, please stay in contact with your fellow indie devs over on the Discord or the discussions pages. And please come back next week as we have a big stream coming up. We will be discussing what is new and exciting in Unity 6.1. We are bringing in some big wigs, some big names with a ton of information, making big decisions. That's on April 24th. That's 12 p.m. Eastern Time, 9 a.m. Pacific, or 5 p.m. GMT. Ask your questions, bring them to the table. Let's discuss what's new and exciting. And I don't know, but maybe they'll give us some insight into what will be coming down the line as well. Unity community, thank you to each and every one of you for coming and joining us at these live streams. It's my entire job, so I hope that you guys have a fantastic time. I encourage you all to continue to join. We're here every single Thursday at 9 a.m. Pacific time, 12 noon Eastern, 5 p.m. GMT. And in May, June, and July, we're looking to bring it up to Tuesdays as well. So if you have anything you would like to see, come to the streams. Talk to us about it. We want to know. We have some very cool things in the pipeline. Circling through this chat here, Matt Spawnholes, C. Stratton, great to see you, Rogues, Shadow, Serge, Martin. Thank you, everybody, for being here. We'll be back next Thursday. Until we see you all again, my name's Jackson. Have a great rest of your day, everybody.